Hello, you're welcome to Calculations in Chemistry with Mr. Hayo. Today we are looking at another topic in chemistry that we call isotopes. So this question is from isotopes, this calculation of relative atomic masses. Now, before I solve this question, let me just in a minute quickly revise what isotopes is. Okay, isotopes are atoms of an element with the same atomic number, the same number of protons, but different mass numbers due to different number of neutrons. Okay? For example, isotopes of oxygen are 0, 16, 7 and 0, 17, 8. 0, okay, oxygen 16, 8 and oxygen 17, 8. Another, okay, example of isotopes are isotopes of chlorine. Chlorine, we have chlorine 35, 17 and chlorine 37, 17. So you can see, look at the first example. The atomic number are the same, 8, but the mass numbers are different. One is 16 and one is 17. For chlorine, the atomic numbers are the same. They are both 17, but their mass numbers are different. One is 35 and one is 37. So this is what we call isotopes, and it is from the isotopes of elements that we calculate relative atomic mass. Relative atomic mass is an important concept in chemistry that we used in calculations. This is what we use to calculate relative molecular mass of compounds. We are going to learn that one later. So let us learn how to calculate the relative atomic masses of elements. Every element, okay, has its own calculated relative atomic masses, and for most elements, the relative atomic mass are not whole numbers. They are always in decimal because of the forms of isotopes of the elements. Alright, so coming back to this question, this is a question now. An element X, we don't know the elements, has two isotopes, X65, 30 and X36, 30, with relative abundance of 60% and 40% respectively. You know, when you hear the word respectively, it means that this 60% is for the first isotope, the 40% is for the second isotope of the element. Find the relative atomic mass of the element from the name relative atomic mass. So anytime you are calculating relative atomic mass of any element, you use the atomic mass, the number that is called, which we also call the atomic number. That is what you are going to use to calculate it. These are the percentage composition of those isotopes. So the answer, our relative atomic mass is going to be, solution is going to be 60% of the atomic mass. 60% of 65 plus 40% of the second atomic mass. 40% of 66. Okay? So when we do it properly, 60% of 65, of course, is going to give us 39. 40% of 66 is going to give us 65.4. Sorry, 26.4. Okay? Of course, you know how to do this. You just do 60 over 100 times 65. You arrive at this. This one, 40 over 100 times 66. You arrive at this. Now, when you now add the two together, you're going to get 65.4. So 65.4 is the relative atomic mass of that element X. Now, before the end of today's class, I would love to solve one more question on this isotope. All these questions, they are taken from WAEC past question, NECO past question, and UTME past questions. So I can see that it's very simple. So let's solve one more question. One more question. We have the question is two isotopes of Z with mass numbers 18 and 20 are in the ratio 1:2. Determine the relative atomic mass of Z. Okay, so this is another way the examiners can set question on calculation of relative atomic mass. You know, the first one that we solved, you are given the percentage composition of the isotopes. But in this case, what we have is the ratio of the isotopes. So anytime you have the question in this format, okay, you know, we have these are the mass numbers 18 and 20. So we have the first isotope Z18. Okay, the second isotope is what? Z20 in ratio 1 to 2. So whenever you have a question like this, the first thing you do is that you find the total ratio. The total ratio. That's the first thing you do. And that is 1 plus 2. 1 plus 2, which gives us 3. So the total ratio is 3. After you have gotten the total ratio, the next thing you will now do is just like in mathematics, when you are solving proportion, when you are sharing a quantity or an item among many people, the way you calculate proportion. So that's the way you're going to do it. So instead of using percentage, I'm going to use fraction. So to solve it, the answer is going to be 1 over, this 1 is for Z18. It's going to be 1 over 3 times 18. Don't forget, when you are solving relative atomic mass, we make use of the what? The mass number or the atomic mass. So to solve, it's going to be 1 over 3 times 18 plus 2 over 3 times 20. Okay? Permit me to play here. So to finish it up, it's going to be relative atomic mass is equal to 1 over 3 times 18 plus 2 over 3 times 20. Okay, 1 over 3 times 18 plus 2 over 3 times 20. So that will give us 1 over 3 times 18 will give us 6.0. 2 over 3 times 20 will give us 13.33. We press it with the calculator. So the final answer for this question is 19.33. So that's the answer. You can see that it's very simple. Okay? It's just knowing the process and how to do it. So this will be the end of today's series. We have solved 2 questions on relative atomic mass. Watch out for the next series on this topic. Please kindly share with students, especially in secondary school, those who are about to, those who will write WAEC, NECO, and UTME by next year. I intend to do all the calculations in chemistry by the grace of God. That's why, as you can see, I started from the beginning. And this is like SS1 work. So I'm going to do it until we reach SS3 work. So it's a long, it's going to be a long process of teaching. So, and I'm not going to rush it. I'm going to be doing it gradually because I want you to understand it. So thank you for watching and listening. See you next class.